we're going to start now. Well, 6 minutes past 4. And I hope we're going to finish at 5, because actually we have a very nice speech at the BNO this afternoon at 5. And I will share the link with you when we are finished with this one. We have 5 talks with 7 speakers. So they're going to have combination of speakers, all about circular economy and then all about repair maybe, and with different multiple perspectives on repair. And this is the list of all the talks and also the order of the talks. So first, Karel will tell a little bit more about circular cities. Then Sagar and Beatrice will focus more on diagnostic and the user aspects of that. Astrid, as the third presenter, will, well, I call it Lekkersamenklooien. I think it might be a nice one. She's really an expert in bringing kids and the younger generation, I think, more to making and hopefully also to fixing stuff. Then 4th speakers will be Alma and Julieta on DIY repair and 3D printing. And of course, Francesco, as one of our alumni and really appreciated graduate students, I think. He graduated on repairability of vacuum cleaners. And I think he will tell us the story about his perspectives from an industrial company. So this video seminar is videotape. Keep that in mind. If you don't want to show up in the bar, then actually just turn off your camera. You can ask questions via the chat. We have a chat. I will follow that chat now and then. And if you have any questions or remarks, we can come back on that later. We have about planned 8 minutes per talk, so that's going to be quick. Francesco, 8 minutes. You're on the last one, but you only have 8 minutes, and Juliette as well. So keep that in mind. We'll keep the clock timed. Vincent will put you at it when the time is finished. And after that, we'll have still some statements we wanted to discuss with the panelists. So first, I would like to ask, Karel to join in and share his screen with us, and then you can start presenting. Thank you very much. Karel, are you coming in?
Yes.
Excellent.
Here it is.
Then yeah, there you are.
I suppose everybody can see it and hear me. Yeah. So 8 minutes is it's short, but it's enough. So let's start. Good afternoon, everyone. My name is Karel van der Berghe, assistant professor at the Faculty of Architecture and the Built Environment. And in this short talk, I will talk about some research we have done with some colleagues about the role of space in the circular economy. As an introduction, this is just an open door. In 2030, we have to have a 50% circular economy. In 2050, a 100% circular economy. But what does this mean? Well, the Netherlands have adopted this policy in an official document stating that indeed the Netherlands want to become fully circular in 2050. And by now, other institutional levels have also taken this into charge, like The Hague, City of The Hague, or Rotterdam, just to name a few. The question is then, where are we now? We are really good by now in designing circular products like Philips or Mitsubishi electric elevators. And we are now upscaling that to a larger scale. So TU Delft, Boken, a few years ago, started to test this circular design on buildings. This was for a long time on our bicycle parking. Now it's moved to the Green Village, some way a bit further on the campus. But just to test what is modular design, how can you design a building that can be adapted and be reused multiple times. And now architects have adopted this view. This is, for example, a building design that will be built in The Hague, in the Binkhorst area, Bing blocks, completely a circular design. And if you think about it, if we would multiply this amount of circular buildings, after a while, we end up in a vast circular area. Of course, is that true? It would look a bit weird, of course, like this, but just the idea that all buildings would be circular, at some point you are really on a larger scale thinking and acting circular. Well, of course, there's a tension between the level from the world's view, the circular economy, and from bottom-up circular design. And in more scientific terms, it's a tension between network and places. So from a circular economy, we are talking about economies and sectors. We are talking about chains and flows. from bottom up, we are talking about design and products. And at some point, they come together. And this you can call a circular area or circular region. But how does such circular area looks like where chains and flows come together with the design of products? Well, to make it more concrete, we looked at the city of The Hague, and this is, for example, the amount of materials in the build environment in The Hague, the city of The Hague in the Netherlands. And by far, concrete is the largest material present in The Hague. Concrete is quite interesting to look into because concrete, per definition at least, theoretically, can be used 100% circular. Of course, there are other things to take into account, but theoretically, you could say that concrete can be reused fully 100%. So if you think about it, it can be circular concrete. Then we looked in The Hague, what is the amount of concrete available and what is the demand of concrete? And like you see here, light gray is the demand and gray, darker gray is the supply. It almost fits. So if you think about it and you take into account that concrete can be 100% circular, within The Hague, you could build buildings with the concrete that is available, that comes available within that region. Well, this means that production and consumption can be matched. So the supply and demand can be matched. Of course, you need a step in between that maybe changes the concrete a bit into another form, etc., etc. So you need reproduction functions that can link the supply and demand. And this links it very much to places. But here, the flows of materials between supply and demand have to land somewhere to be resent into the world again. And this is where networks come together with places, also within time. So we made this concrete again. The Hague is also quite interesting because The Hague is a very residential city. There's almost no industry there. There's only one industry area left, that is the Binkhorst. This is here on the map you can see. And in the Binkhorst, there are two concrete plants. So in fact, you could conceptually think that these could be ideal to match the supply and demand to each other. However, these concrete plants are being closed or will be closed because of the need of circular housing. Let's say that these housings will be circular, so these will push out these functions. To the left, you see all the distances between the origin and destination of the need and the supply of concrete towards that concrete plant. Concrete is also, that I didn't mention, interesting to take into account because concrete has only a limited transportation distance. It can only be transported for 15 at 20 kilometers. So if the concrete plant in The Hague will be shut, the next one is in Delft, TU Delft, next to the TU Delft even. And then to the right, you see this, we calculated the distances from origin and destination towards Delft. Although it's not that far, The Hague, Delft, the amount of extra miles that we need to cover are significant. So to take, for example, the year 2020, in 2020, there was almost 800,000 tons of concrete needed. A full truck is about 41 tons. That brings it to 18,500 total trucks, that's 51 per day. This is 130,609 kilometers that these trucks have to cover. To bring it more to something that you can understand, that's 3.2 times around the world. This is from The Hague. If you take that from Delft, it goes to 7.7 around the world. And in a circular economy, this is only single distance. In a circular economy, you have to, in fact, double it. So per extra kilometer that concrete has to be transported, 18,500 kilometer extra truck distance is needed. And if you calculate that in CO2, it goes from less than 1 million ton to almost 2 million ton of CO2 that we expose. And to put that in perspective, the CO2 impact of Schiphol is 13 million. So that's quite considerable. Of course, this is only concrete, but it's the way of thinking that I want to present here. This is the same issue with steel, plastic, organic waste. It's not only about how we design products and how we recycle, it's also where. And the question is then spatial economy. For example, in Politico, there's a huge dossier on the recycling myth, and they go into that. The question we are transporting steel and plastic all over the world, and per se they are circular, but is that what we really want? And these are the decisions that we have to take today to look towards 2030, 2050. So conclusion, there's a tension between network and places, and we really need to think about where do we want to land these new economies, and we are steering them today already. I hope that was within my 8 minutes, but this was my presentation.
Perfect, perfect.
Then I stop sharing.
All right, thank you very much, Karel, for this very short introduction, but I think you hit the point actually on transportation. I think we always discuss with our students the last mile. Now we got this internet, everything is bought by internet. And how about this last mile? These trucks coming into your streets, bringing all your stuff, and you have to bring it back again because actually you always buy two pairs instead of one pair. And I'm amazed because I know that, for instance, the concrete has globally the highest impact in total. And so it's a big issue, especially if you look at architecture.
Yeah.
Yeah.
Well, the paradox is in fact that the Binkhorst is now promoted as it will be a circular area with a lot of circular buildings. But in fact, the environmental gains we will have with these circular buildings will be vastly outcompeted by the extra miles we have to cover. Even if they become electric, still you will lose a lot of environmental deficits here. So that's a bit the paradox here between circular area design and the functions we need to have those circular area designs.
Yeah. Well, maybe Jan has a question on this topic. So Jan, can you come in for your question, because there are alternatives, isn't it, Jan?
Yeah, sure. Hi there. Thanks a lot, Karel, for your presentation. Yeah, exactly. So I was wondering, why do you focus on concrete? Because as far as I understood, mostly at the moment it's downcycled from buildings to road buildings. So you haven't really touched upon whether it's possible to leave it at the same quality, that it can be reused. At the same time, I know from a colleague in Utrecht who's exploring the circular bioeconomy that wood is a really interesting material to use and substitute concrete more in buildings because it can store carbon. And it's a renewable material, yeah, it could substitute concrete in some applications. So I was wondering what you think about that.
No, very good question. Overall, I'm not pro or contra concrete. It's just a way of thinking we wanted to explore. But on the other hand, if you think about the discussion with wood, indeed, of course, wood would be way more better to use for building our buildings. But at the moment, our stock is completely concrete. So if we want to replace that whole stock with wood, well, then we have to still think where that wood will come from. The moment we have all the wood in our buildings, then we can really use it circular. But until then, we are stuck with concrete. On the other hand, indeed, now concrete is mostly downcycled to be used for building roads. Completely agree. But theoretically, you could remake concrete into new concrete. So you can, even if it not fits, you break it down and you can remake it in a, how do you call that? Floatable concrete to be used again. So then in fact, it's first downscale and then upscale again, but it remains the same, of course. Energy, etc. You have to take into account, of course, but conceptually, it is usable. We could also look into steel, for example. Steel is also 100% circular product, but steel can be transported the world around. So that makes it way more difficult to bring all the variables into account. Yeah. Concrete can only be transported 15 to 20 kilometers because it hardens out otherwise.
Right. Yeah, thanks a lot, Karel.
All right. Yeah, I know something about plastics being recycled. So for instance, garden furniture, if you want to recycle it, and I think lots of recycling companies thought about that one, just picking up the garden furniture when you buy new ones. And it's the issue is that it's going to be sent out to China to be recycled over there and put into granule pellets again, and then being reused in injection molding machines, obviously also in China. So actually you're just, well, transporting a lot of waste materials or materials which are perfectly reusable around the globe. And the question is if that's a good thing to think about. So All right. Well, let's talk about it later on, Karel, because actually you're setting the tone already. So, what are the issue with the circular economy? And I would like to invite Sagar to present. There you are. You already have shared your slide. So, Sagar. We don't hear you, Sagar.
Yep. Are you able to hear me now? Hello?
We hear you.
Yes, we
Okay,
do
great.
hear you. Yes, go on.
Okay.
Go ahead.
Hello everyone. I'm Sagar and I'm with Beatriz Pozo Azros. We are collaborating on the project observational study on diagnosis. And we are PhD researchers in circular product design from industrial design. Yeah. And firstly, so we talk about repairing. So there are 4 processes in repairing. Firstly is identifying what's wrong with the product. Second is to disassembling to the faulty component. Thirdly is repairing and replacing the faulty component. And fourth is about reassembly. But let me get the pointer. But the second, third, and fourth are only done if it is needed. But the first point about identifying what's wrong with the product um, uh, is quite required, because without this, the other steps cannot be taken. And easy and effective diagnosis might promote repair to take the product to repair the products, promote the consumers to repair the products rather than replace it. So in the current literature, it's mostly focused on technologies to monitor and recognize fault. For example, integrating machine learning and smart products for diagnosis processes. So looking at the literature study, what we see is there is a lack of user study research on what process do conventional users follow for diagnosis process, and how design of the process influences the process. Design of a product influences this process. So we conducted a study with 24 participants, 12 with some repair experience and 12 with little or no repair experience. And we created a control fault in 4 different products. Firstly was a vacuum cleaner, so we clogged the motor. Second one, in the radio, we unplugged the speaker component. In the third, we had a coffee machine where the sensor was damaged. The water sensor was damaged. And in fourth, it was a blender where the safety pin was broken. So these are mostly the common faults that, so we try to stimulate the most common fault that normally happens. And we created a user study where we asked the users to find out what is wrong with the product so they can use the product and see, trying to figure out what exactly went wrong with it. And during the process, we asked them to think aloud. And when they are disassembling, if they have to disassemble the product, if they cannot progress for a while or give up, we would try to help them with one step on the in the process. So we observed and recorded this process. And at the end, we interviewed them regarding their experiences and the hurdles. So during the analysis, what we identified were 3 different strategies a user takes normally during a diagnosis process. So first one is a pinpoint test. So we tried to cluster them, cluster the diagnosis strategies they use. So for the first one is a pinpoint strategy. So this is most effective strategy because if the user has a correct suspicion of a possible component at fault, they directly go to that component, and that is the best way possible to do it. Second is the systematic strategy. So user has an idea of general cause of the failure, but doesn't know what exactly is wrong with the product. So he tries to determine by looking at the component or looking at cues on what exactly is wrong. And third is an unstructured strategy. So user do not have any idea of it, and most of the actions he does is in a borderline of randomness. So what we find, so in the process, what we find is that there are 3 different processes that user goes through for fault diagnosis: fault detection, fault location, and fault isolation. So the fault detection is actually identifying a malfunction. So to identify that there is something wrong with the process, a product. And second is location, is determining the possible cause of the failure. And third is isolation, which pinpoints the component at fault. And what we observed is that the location and fault isolation is done quite iteratively, where someone says, okay, maybe a component, for example, the speaker may be at fault, and he goes to the speaker and checks if it's faulty. And if he doesn't find it, then he comes back and then tries to make another hypothesis. So what we find in the results is that we did compare with repair experiences between two different users. One is with some repair experiments, another one is with little to low repair experience. What you find is that although we see like a general trend of user with some repair experiments having higher averages in pinpointed and systematic strategy and less in unstructured strategies, we do not find any significant differences in the diagnosis strategies they follow. So that indicates that repair experience is not that significant in determining what strategy a user follows for diagnosis. However, during the disassembly process, as we said before, that we ask them if they get stuck for more than 5 or 8 minutes, we help them. People with no repair experience, we require much more help than people with some repair experience. So this means that if a diagnosis of product requires disassembly, repair experience is influential, and disassembly becomes a main bottleneck in diagnosis. And so if you want to design a product, you have to minimize the need of, if you want to design a product for better diagnosis, you need to minimize the need for disassembling the appliance. And also, if there is a disassembly is required, then you need to facilitate the disassembly of the appliance. Second thing is, based on the strategy itself, what we see is that the products, what we see is that there is a significant difference. There is a significant difference in strategies that is followed between different products. That indicates that definitely a design is quite influential factor determining how easy a product is to diagnose. So in systematic strategy, participants concretize possible causes of failure by learning how the components were assembled and work together. So if a working mechanism of the product was visible, then this helped guide these strategies. Altogether, what we find is the relevant design. So we looked at the design features. What are the design features? So there are only 4 over here, but there are quite a lot of design principles we found. So these are the examples. And so for example, for feedback of information, error code and having a display in the product really helped the process. While manual was, if the manual had a disassembly process or a very clear diagnosis table on it, then it helped. Otherwise, manual was not that helpful. Similarly, in disassembly, high force snap fits, larger number of screws hindered the process, while if a detachment within the less than 2 action at low force was seen, then that helped the process. So if you put everything together, in general, design features facilitate the fault detection by including easily recognizable signals that direct the users to faulty component. It can guide the users for fault location by providing feedback to the user during the diagnosis, and can provide quick understanding how components work together if components are easy to access and is visible. Finally, ease of disassembly could have a strong positive impact towards a successful fault location. Yeah, that is it. Thank you very much for listening. Yeah, I'm happy to answer your questions. Yep, stop the share. Oh no, I think I muted everyone. Hello?
Yes,
think we
now.
Okay, yeah.
I'm sorry about that, guys. Well, thank you very much, Sagar, for your insightful presentation. Are there any questions? So we only have room for one question, then we'll move on to the next one. So we still have some time to discuss later on. I saw Francesco still talking as a question for everyone on the materials, but let's talk about that later on, Francesco.
With the previous one, yeah.
Let's talk
maybe
about
a question for Sagar could be about the service manual, because with Giulietta, we did a study last year, and it was about safe by design, so self-repairs and how to make it safer. And what we did was to give to participants a quite simple and easily readable manual, but what we saw is that the participants just didn't even look at it, or if they would look at it, they would not really pay sufficient attention to actually understand how to carry out the procedure. So yeah, I was wondering if you actually instead found out that the manual can really be helpful for diagnostics in your study.
So for manual, out of 24 participants, only 6 participants actually asked for the manual. But within the participants, they did not find the manual that helpful, because we provided the manual which was given by the product the product company, and they did not have specific troubleshooting very clearly laid out. So in general, manual did not help, but in one case, is for the vacuum cleaner, the troubleshooting was quite clear, and that helped them determine, okay, so this is not the filter's fault, this is not the hose fault. So he was able to cancel out quite a lot of suspect because of it. So yeah, if there is quite a lot of manuals that really doesn't help them. So it really depends on the manual, I would say.
Yeah, I think that was one of our conclusions from the previous research that we did together, well, Francesco and I. It was about safety in self-repairs. And one of the follow-up research questions that we proposed was exactly that. So Vincent is also mentioning that it's the age of the YouTube manual. So we didn't really have time to explore those possibilities and then see what is the best way to provide information. What I found very interesting, and it's also related to this in your findings, is that you mentioned that the user really benefits from understanding how the product works and how components relate to each other within the product architecture. So that already gives a lot of information to the user. So one of the other proposals was to include all of these guides as part of the product, you know? So like all of this, we're already very familiar to receiving feedback from the product when we are using it. So also maybe receiving more feedback while we're trying to repair it would be a nice analogy there. But yeah, I think it's interesting to see those things in your research.
Yes, indeed, like definitely. For example, just a small simple click function when you detach something, that really helped them. Okay, it's now detached, or if you click it back, it's attached. This small feedback really helps them like be sure, okay, how exactly this should be taken apart. So yeah, I completely agree with you.
Yeah, also adding to that, people tended not to ask for the manuals just because they would tell us they would not find the information they expected to find there. So disassembly information was not there, and most of the problems that they had were simply not mentioned in the manual. So they were just like, we don't think it's gonna be useful anyway, so we don't even want to check it.
Yeah, and they're also going, right? Like everybody wants the information that they want at the right exact moment. So that's also people are very impatient. Yeah.
All right. Well, nice discussions. Thank you. I would like to move on to the third speaker, Astrid.
Yep.
Astrid Poot from, and I'm really looking forward to your presentation, Astrid. So go ahead.
Yes.
Nice.
Yes. Pressure. So everyone has a good view on my screen. Sagar, I really liked the findings you explained in your presentation, because I find actually in the attitudes of children towards repair, there's a lot of similarities. So this is, I am a designer and also the founder and the chair of the foundation Lekkersamenklooien, which translates to happily messing around together. So the messing around bit is rather important in the work that we do. And here on the screen, you see my father with the good hair. He's actually on his workshop and he is building very big radio telescopes like these in the north of the country. So it's actually a super professional workplace that most children never ever see in their lives, modern day children. And on the right in the little drawing, you see me. And my father used to call this, we're just hanging out together. And my father passed away recently, so I have a very warm memory in this situation. And he actually made me into a maker. And now I have children myself, and then there was this awful moment in time where my daughter was only interested in buying the new bag for the new season. And throwing away her old bag, and every time she encountered something that was broken or she wanted to make, she always thought she had to buy stuff before getting into it, and this really made me sad. So then I looked into other children and found that this is really a common problem, and so we founded our little foundation, and we do all kinds of stuff that engage people in using tools. So being able to learning skills so they are able to use tools in a proper way, which is very needed. And we try to be very friendly and make it very easy. So we make thinking boxes that children can borrow from school, and then they can just experience a soldering iron, common tools like that. And we don't tell them what to make, we just tell them to experience the tool. And one of our biggest products is this one. This is a poster that has all 50 tools on it that we believe all children should be able to use before the age of 12, or experience at least once, because hands-on experience is really important. And Sagar, that's also what you said. You said that the people who have more experience with repair need less help in fix or getting into a machine. This is exactly what we find as well. When you experience one tool, your attitude toward the next new one is different, because you think, I learned that one, so I can learn the other one. So I think it's really important to teach children this hands-on knowledge. You can also see that that a crochet needle is there, but also electronics. I also feel, yeah.
We don't see the slide.
You don't?
No, we see the PDF in its complete form. So.
But you don't see the slide.
No,
ooh,
I think you shared this wrong screen. Yes, this one. This one. Now I see it.
This is good.
But now this is the screen we see. So we see the create PDF, combine files, and that kind of stuff. So I think you.
So do you see blue now?
I see blue now. Yeah.
Okay, I'll just keep it like this. So the full screen did. I apologize. I'm sorry.
No, that's no problem.
But you did see this image or not?
Now I do see the image.
Yeah. Okay. So this is the poster with the 50 tools, and we found that in making children into makers, the attitudes of the parents is key. So when you look back a little bit in time, for instance, the parents who are now the parents of young children, they grew up in a wealthy world. Most of them, not all of them, but a lot of them, and they associate repair with poverty and lack of things. And when you do well, you buy new stuff. That was a sort of an attitude that was adopted when there was more money available for everyone around. And what you see right now is that making stuff by hand is actually, again, a luxury activity. So you do it to just unwind from all the digital things. You pick up knitting. So it's sort of shifted in the wrong direction. So this little boy in 1985 maybe saw his mother repair a sock, but now for his own daughter he would buy new socks, because it's cool to buy, because it shows you're wealthy and doing good, and it's cool to have new things. But also, and this is really a difficult one, new things are cheaper. So if you want to buy a little sweater from, for instance, Primark, it's much cheaper to buy it than to make something similar yourself. So that's really, it's a big thing to go up against. So the barriers for repair are really big, because people lack space, especially in cities. I found that most children don't have a toolbox. They have an iPad with Google on it. That's the toolbox, but there's no big saw because you have to keep it under your bed or something. And most people associate craft work with poverty. So again, the modern tools are more popular in the house than the old-fashioned tools. So there's also no tools because everything is on the screen. Well, everything is on YouTube. We had it in the chat right now, but it's not, because as a child you learn to make with your parents or with someone else. You learn it from an actual person. Another thing is, of course, time. Our time has been designed away from us with all the distracting screens we surround ourselves with all the time. And we have a generation of parents who lack the skills. I learned all the old-fashioned skills from my mom, but then again, I am much older than the parents who have now children in primary school. And it's the attitude we associate repair with poverty or with super luxury, but that's not for everyone. So it's a big thing to change. And what I also found, for instance, in buying gifts for children or creating activities for parents to do with their child, is that they are very afraid that they're not very cool. So parents think that this computational thinking tools where you do sort of fake programming is really attractive for a child, way more attractive than, for instance, making your own rope or creating your own saw to experience how the teeth should be, or learning crochet or soldering, or, well, you can see it in the pictures. But when you talk to children, most children prefer to do these sorts of activities way over doing stuff with screens. There was a research done by IKEA a few years ago, and that was really disturbing because it showed that I think 75% of children prefer to play with their parents than to using media, whatever media, including gaming. But parents were afraid to play with their children because they think they wouldn't be as cool as the media the children use. So the parents have this strange attitudes towards wanting to be cool and not being able to. But in fact, the answer is just be normal and you're super cool for your children. So make normal stuff and the children will feel much better, because when you learn a real skill, you're proud, you feel independent, you feel you can solve situations that just come in your life. So the children feel much stronger than actually when they get a really high level in Fortnite or something. So it's a really big difference in self-awareness for the children. So what we try to do, we try to be very friendly about it. So I showed you the poster with the 50 tools. So we make friendly, nice little nudges where we actually tell people, just get to know your tools. Don't make stuff, don't make something really difficult. Just experience what you can do with it, whatever. We encourage children, for instance, to unroll a whole a package of tape instead of using it the proper way. Just also explore the improper ways to use it. And then we find when they feel familiar with the tool, they actually like to repair stuff because it's the adult way of using tools. And I'm really convinced that when you have a lot of experience with stuff like that, you also recognize valuable materials. You understand that sometimes you can upcycle or recycle things, or your attitude already changes. And then finally, these children will become designers like you lot, the people who are very conscious about creating new systems to change and improve the world. So it's really important to keep this flow of young people going so we can actually change the world in a few years ahead. So it starts really easy and really small. And what was funny, I put a little survey out on Twitter preparing for this lecture, and I asked people, what are the essential repairs that everyone should be able to do? Well, you can see someone in the illustration. I like it very much that people were putting first aid also as a repair, so a dramatic bleeding nose, but also someone having a heart attack, which is rather hard to put on children, I think. But also someone who's sad was also considered a repair, to fix someone who's sad. But of course also to attach your buttons again, to fix your shoe with a flappy sole, to fix your flat tire. So in 2 or 3 days, we had 52 essential repairs for everyone. So maybe we can also make a nudge poster. You can tick the boxes also from this to get people into chasing this attitude towards repair. So be friendly and make it very easy. So something you can tick the boxes is for parents a very relaxed way to raise their children, actually. And I learned not to judge that, but to actually use it in the work we do. And I hope we changed some children already. So that was my presentation.
All right, thank you very much, Astrid. I'm amazed. I'm Yeah, I'm flabbergasted a little bit. I have kids.
Flabbergasted.
Yeah, I've got kids of 16-year-old, my eldest one, and they all, well, they prefer their screen, I know, and I find it very difficult to get them in my work shed, where I have all the stuff there, and I've tried and I tried it, but it's really difficult, Astrid. So, do you have any tips for me?
Yeah, well, the main tip is that there's a sort of a phase in growing. 12 is a sort of pivot age. So everything you encounter before the age of 12 stays with you, whether you like it or not. I learned to code when I was 9. I thought it was ridiculous and stupid and everything. But then when I was in my 20s, I actually became a programmer for a period of time. So everything you encounter before the age of 12 is something that you understand, that you can sort of do. And after 12, it's more difficult because then the patterns are really there. And after 12, you have this period where you feel very insecure and new things are very difficult. And when you're really good at gaming, let's just stick to the gaming. So maybe you're a bit late when they're already 16. But what I found mostly is that if you frame learning these skills as a social activities for children and parents to connect on the initiative of the parent, that's actually a really good thing. Most children, for instance, like to bake together with their parents. And it's this moment where you can discuss the awkward topics, right? If I'm in love with someone, I'm not sure if he loves me back, stuff like that. So it's also about creating social situations where the making is actually sort of on the side, but while doing it, of course, you get better at it. So you can maybe choose that approach, or I don't know. And also what I try to be very firm with my children about it. So if they refuse to do something, well, I refuse it too. So, hey, what can we do now?
Who's going to do it then?
Yeah, but when they're 16, maybe you won't win that battle anymore. So there's some battles you won't win, but it's also about being the example. So I'm not sure how much time you spend on your screens, but when you're always on your screen and this is the image your children see, this is what they learn, that is the thing to do. Whereas your children see that you fix everything and you make your own whatever product, then they see that's actually a choice you can have. And maybe you don't see it at the age of 16, but when they're 18 or 20, when the adolescent storm sort of calms down, then these beautiful things will emerge that you put in at the early age. Yeah. So it's really down to the parents to create this new generation that will become designers like you.
Yeah. All right. Thank you, Astrid. So that gives me some hope because I try to be an example and I fix stuff at home and
cool.
I make stuff at home and I never force them into it. That's the one thing I never did. I hope they saw it and then maybe it's getting normal for them. And that's exactly what you tell me.
Well, in 2 years, probably.
Yeah, I hope. Well, one of them is going to the IPO now, so she's thinking about it. So
great.
There must be a maker inside, I hope. There are many questions I see. Also, Karel has a question or a remark maybe. Karel, can you come in for a small bit and then we can move on to the next presentation?
Yeah, if children don't see work, they don't know that exists, and that's exactly. A point that we have in spatial planning. What I say in the chat, we moved all these functions out of the villages and cities, of course, from many important reasons for noise or logistics or smell, etc. But the downside is that you don't see any more work, so you don't know that exists in that way. Yeah. So that's a huge thing that exists, of course.
Yeah. I also have one question. I think it was asked private, so I'm not gonna share who said it, but someone asks, isn't it dependent on whether or not your parents are handy? And I remember once having a parent in front of me. He was a sort of a super sports guy with a tight shirt, covered in tattoos, and I did this sort of talk about the role of parents, and he really looked like he was going to confront me with my talk. And then but when he was close to me, I saw that he had tears in his eyes, and he says, I have this twin, 2 boys, age 7. And I, as a small boy, my father used to tell me I wasn't handy, I couldn't do anything. So he never taught me anything. But then his eyes were really wet. And then he said, but now I understand that you can learn together with your children as well. So if you consider it social time and not so much focus on, I'm a super skilled person at fixing flat tires, if you're not, then you could say, well, this tire is flat, let's just try if we can do it together and make it into a social situation. And for him, that was a very big pointer, because he was actually suffering from this idea about himself he got from his father. And because they were doing financially well, there was no need for him to learn all these things. But now he regretted it because he wanted to do this stuff with his little boys. So being not handy is a threshold, but also when you consider it social time, then it's not a problem anymore, but it's as a change in attitude. Hello? Nobody there?
Yes, am I there now? Yeah, thank you very
Yes,
much,
you are.
Astrid. I'm sorry. I mute myself too often. I'm not getting used to this kind of stuff. Thank you very much for your presentation, Astrid. And I think we have to, there was one question, where can we see your work? And samen lekkersamenklooien.nl, isn't it, Astrid?
No, it's not.
Oh.
Let's see if I can share it. Oh, sorry.
So you can share
I
it in the
sent someone
chat.
a private message, which I shouldn't have. Suddenly I'm in a private message. I don't know why. It's lekkersamenklooien.nl.
It's different.
But I'll share it in the chat later on. But and there's also a lot of rather a lot of the materials we make are translated into English. So there's also, for the international audience, there's some nice bits to get.
Excellent.
Yeah, thank you all.
Well, thank you very much, Astrid, for being here. And well, let's move on to the next presentation. It's Alma and Giulietta. I don't know who's going to present. Giulietta or Alma?
Yeah. Hi, I'm going to
Hey.
present.
Nice.
Can everybody see the presentation?
Yes, we do. Go ahead.
Cool. So, Alma and I, we're working on the shell repair project, which is, the main, can you see that? Yeah. The main focus of the shell repair project is to decrease the waste that comes from electronic and electric consumer products by scaling up or supporting this citizen repairs. And they want to do it through the use of digital tools. And these digital tools, well, they mean several things. Because they aim to collect repair solutions. So I don't know, for example, repair manuals and 3D models of spare parts for 3D printing and I don't know, extra technical information, whatnot. And they want to make all of these tools available to individuals and also repair organizations. So, for example, repair cafes. And so in this organization, sometimes we want to repair something and a certain part of these repairs are not successful because we have spare parts missing. So no spare parts sometimes, either they're not available. So the manufacturer doesn't make the spare parts available because they consider that, well, there's a liability discussion going on there. But let's not get into that. Or the product is obsolete. So also not an available part, or it's just not available because. So our department and the focus of our research is to have, to research the possibilities of using 3D printing to create these spare parts. Easier said than done. Because we have a lot of questions, right? So we're just starting our project, so it's actually really nice to have everybody's input today, because we're still trying to figure out, for example, which products. We want to know for which products is it more relevant to do this, or which kind of parts is it more relevant to do this, or feasible to do this, and well, how can we make them available to everybody? So there's this whole complexity going on about 3D printing and whatnot that we have to sort of navigate. And then we have how to make it feasible. How do we make these parts actually work and repairs last and whatnot? So in order to answer all of these questions, we've been looking at other projects that other master students have been working on. So for example, we have a master student who repaired a bunch of products with 3D printing, and then he generated guidelines to reproduce and design and then manufacture these spare parts through 3D printing. But we also have people focusing on 3D scanning, almost DIY 3D scanning skills and whatnot. So there are quite a few people working on this who have worked on this. So we've been reading those a lot. But we also went on, and Alma and I have been trying to do our own case studies. And so well, this was the one that I've been working on. This is a kettle from one of our colleagues at the department, and this was broken. I think the kettle fell, and so these two components were broken. These components are like the top ring that seals the cap of the kettle, and then we have the switch. So the switch activator, let's call it. So they were broken. And the first step in order to design this 3D parts, 3D printable parts, was to really get to know the object and then really understand how these components relate to the other components in the product, right? So how does the activator actually activate the switch here on the right? But also how do we get the right dimensions and whatnot. So I did a first try for the for the switch, and it melted. It was a very quick tryout and whatnot. So I learned a lot from that. And yes, then I went into more iterations. In total, it took me 3 iterations. Actually, it's gonna take me 4 because I just recently burned another part, but we'll talk about that later. So we found out, Alma and I, we've been discussing, we found out that it's not actually, it's not a very big part of how we're gonna make these parts available, is that we're gonna invite a lot of makers to create these parts, but actually the process of creating the part is very complex. And we found out, for example, that it takes, yes, 3 iterations. And yes, the print of the switch and the print of the top upper ring that you see here, they don't take over 3 hours to print, but they've been taking quite a lot of time in 3D modeling, and also a lot of effort in the design of the part itself. So a very big finding is that this we have to really study this process, because it's not really about exactly copying the parts that we see or the parts that are missing, because we're not actually reproducing them. So you have a part that was originally designed to be made in injection molding, but now you're reproducing it to 3D printed. So it has to be a complete different part, and it seems very obvious, but it took us a few tries to realize this this big thing in our project. So it becomes quite a complex design process and not so much a reproduction process. So yeah, the final result of the kettle, the upper ring didn't resist the heat again, so that's another part that's gonna go to the trash. But I already have a plan for this, and yeah, the switch is still working. So that's the good part of this repair. But yeah, so some of the availability challenges, for example, is that we have a lot of 3D model platforms, but spare parts are rare. So you mostly find like small articles that you can 3D print and whatnot, but you don't find a lot of spare parts. And the ones that are available are very hard to find and whatnot. And yeah, so can we make a specialized platform for 3D printing for repair? Another big challenge is gonna be to identify what kind of information do we have to provide according to the different levels of knowledge of the different repairers. So there's gonna be people who haven't touched a 3D printer in their lives, but then there's gonna be people who have. And then we have, okay, so who's gonna be generating all of these CAD files? This is an example of what we were mentioning about the available 3D model platforms. So if you Google repair in the Thingiverse, the first result is a repairable, like a part to repair your Ethernet cable, but then the rest are something else. And last, so I don't go too much over time, is feasibility challenges. So how are we gonna navigate this 3D printing complexity? Because there's different materials, different printers, different technologies, different software, different and it also has a lot of changes within each print, right? If you have the same printer and you print one day and the next day you print again and it was humid or it was hot or it was something, it's also going to be different. So how do we navigate all of this? Yeah, how do we adapt the design to cope with these differences, and how do we guide users through this design process? And yeah, also how do we adapt to all of these things? An example of, this is my last slide of what I'm mentioning here, is this is the original part on the left, and the 3D printed part on the right looks completely different, right? Like it's not a copy of the part on the left. It's just an adapted version for this specific manufacturing process. And that's where we're at. And we would really like to hear your comments.
Yes, thank you. Thank you. Very nice. And nice to see the bicycle of my son. So in the end, are there any questions? So we can, let's love your hands-on approach. Excellent. Yes, we do agree on that. I think we're still playing around, Astrid, at the university. And I think we're never going to stop playing around. That's a good thing, isn't it, Giulietta?
Yeah, we like this playing around, burning things approach, or at least I do.
Giulietta, did you try also different materials or just PLA?
Yeah, well, I tried PLA, but I also tried ABS. So we already have some, well, we've used actually your research that you did for KLM to navigate like the material decision making and whatnot. So yeah, I've been trying different things for the heat resistance, but it's a combination of both. So yeah.
I think that a very interesting material is also PETG, and there are some interesting startup companies in the Netherlands that produce recycled PETG. So maybe it's also an interesting idea to get in contact there. I think in the code there is also Tim. I know that he's a super expert of 3D printing, so he can definitely help there.
Tim just want to glue stuff, so isn't it, Tim?
Yeah, but true, Fra. We do have a lot of options for materials. I think that's also going to be a discussion in the future. And then I don't know, Alma, I don't know if you are going to agree with me, but I think we also have to realize what kind of things are available out there, right? Because I can give people the exact requirements that you need and the exact material and the exact brand and the perfect printer for this. But then if you go to the Repair Cafe and what you have is an Ultimaker 2 that has PLA, then that's what there is, right? So how do you also allow people to do this without being super expert
in 3D printing? Yeah. Yes, we need to design this kind of stuff also for users who are not very experty, and we want to learn, of course, especially if you want to design parts. It's I think that's the most difficult part. Anyhow,
why not glue parts together, says Tim?
Yeah. Well, I don't know if you have your standard glue at home. It's not that very sticky. I've bought 2 components glue nowadays, so it's even better. But maybe you can say something about that, Tim. It's your last chance to come forward. Tim, you want to say something? No, thanks. All right. Okay. Oh, thank you very much, Giulietta, for your presentation and showing what we're doing at the university as well. And last but not least, I would like to invite Francesco to share his screen and to actually present your vision, or the Philips vision, on repair and repairability.
Yeah, today I feel a bit like the bad guy.
No, you're not. You're definitely not. It's we have to do it together, guy. Yeah. All right.
Can you see my screen? Yeah,
yes.
Great. Okay, so yeah, hi everyone. My name is Francesco. I'm a product designer from Philips. I actually recently joined the company. I did a project with Philips last year for my master thesis that was about design for repairability. I actually did this project with Bas, and now is today coordinating this discussion panel, and Connie Bakker. And then since January, I officially joined the company as part of the circular design team. So there is this a small team of designers in Philips Design that is looking into how to design products for the circular economy. So first of all, I wanted to start from the big picture. So why are we even talking about this today? So Philips every year produce a huge amount of products. We are talking about 200,000 tons of consumer products every year. And if not properly designed and properly managed at the end of their life, these products are probably ending up in a landfill or in the Netherlands are gonna be burned. And yeah, we take this responsibility very seriously. We also see in the recent years how consumers are becoming more and more sensitive to the topic of sustainability. Consumers that before like 5-10 years ago would find the product produced using recycled plastic as a lower quality, now instead are asking for it. They are asking for big changes from manufacturers and legislators, and we are also seeing how the European Commission is really reacting fast on this. And now we see a lot of new regulations coming up from the European Commission, also really specifically for design for repair. So this is a bit kind of the 5 main circular loops that we usually look at everywhere in Philips. There is nothing really new here. They are the usual loops that everybody always look at least for the techno cycle. And as you can see, there is an important loop that one of the most valuable, that is design, service, and upgrade. So we are talking about design for repair, design for serviceability, design for upgradability. And apart the refurbishment activities that we do on big medical equipment in Best, close to Eindhoven, we also do quite a lot of repairs on consumer products. This is something that usually you don't really hear much about, but Philips actually repairs quite a lot of products every year. We are talking about 1.5 million products worldwide each year. And in Europe, Philips has more than 300 repair workshops. Apart from these activities, we are also really pushing for providing products not through a linear model, but through subscription-based models, so access-based models. Consumers can rent the product instead of buying it, and the ownership on the product stays with us as company. So we started with the Lumia. The Lumia was like the first big example that we piloted of consumer product provided through subscription, and now we are really trying to do it more and more. So we recently launched it in Poland. You can rent an air purifier, in US and in UK the toothbrushes, and we are really trying to do it more and more. We also opened a big refurbishment center in Europe in 2018, and today is refurbishing a really huge amount of products every day, and we resell these products that we get back from the e-commerce that previously would have been scrapped. So designing for these new circular models is becoming more and more important, and this really requires a strong mind shift from designing for a linear economy to a circular economy. We are really talking about every time that we have to design a new product, we really have to think about the planned and expected end-of-life scenario or strategy for the different products. So is this product going to be refurbished, repaired? Who is going to recycle it? Which type of recycler, through which process, and how can we ease those operations? So specifically talking about design for repair and disassembly is really important for 3 main reasons. First of all, future-proofing new designs. So if we are designing something today, we really have to take design for repairability in account because we know that new regulations are coming up from the European Commission. It's also important for improving quality and efficiency of the current service and refurbishing operations that are currently going on. And then also for enabling new circular business model, making them economically feasible. Yeah, I was also asked to talk about the big challenges that we are facing, that I'm also facing personally. And one of the biggest one is that Philips is absolutely not yet completely decoupled by the linear economy. So most of the consumer products currently sold by the brand are sold through a linear business model. That means that we have products like Senseo Original that you can see here that are extremely cheap. Consumers loves them not just because they make good coffee, for instance, but also because they are extremely affordable. So we have always to try to find the perfect balance between sustainability, design for repair and circular economy, but also affordability and quality and safety. So for this reason, we have been starting to look into new design methods and tools that can allow us to do specific redesign on the products, very optimized redesign solution in such a way that we can optimize the design of the product without increasing too much the price tag of the product. Otherwise, consumers are not going to be very interested in that anymore, at least in the short run and in the linear model. So this is an example of method that we developed together with TU Delft, actually with many people that are in this call, so with Giulietta, Sagar, and Bas. And this method is a modeling method that is really meant to map the entire architecture of a product and highlight what unoptimized features are present in the current design and that should be optimized in the future generation. So yeah, to really ease the disassembly and make all the operation faster and easier. What we are also doing is try to share all this knowledge as much as possible also outside Philips. So we have been writing papers. We submitted a paper for the Journal of Cleaner Production about this. We also published another paper for the Electronical Spring Conference. And we have been testing this method on more and more product families, also to validate that it can actually be applied not just on vacuum cleaners, for instance. And now what we are seeing is that also other companies are starting to use this method. Yeah, so this was really briefly to show that today I was asked to really talk about specifically about design for repair, but we are also doing things in respect to the different other circular requirements. For instance, design for and from recycling. There are some colleagues in Drachten that are extremely expert in use of recycled plastic, and Philips for years now have been using managing to use recycled post-consumer recycled plastic in some of the Philips products. For instance, the newest Senseo Eco models. So yeah, the next steps that we are now working on is to training the internal community, so designers and engineers in this new way of thinking. We are working on new products, so we are doing new pilots with different product groups to understand with the designers and engineers how we could optimize the current design, and then we are trying to share as much as possible with the wider community. So yeah, that was all. I hope it was interesting.
All right, thank you very much. Very interesting presentation. Kijk. This is taken in Delft, I think. Yeah, that's the Repair Cafe in Delft, I know. Excellent. Yeah. All right, I see there are questions. One of them is from Karel. Karel?
Yeah, well, you covered it after I posted, as the issue with affordability. So when does it becomes cheaper to use refurbished products than the normal products? Will, for example,
sorry, I did.
Will Philips, for example, increase the price of a freshly Senseo and decrease the price of a refurbished Senseo? That would already change a lot, I guess. Yeah, so what is currently happening is that, of course, the refurbished product is, I think, 20–30% cheaper. Otherwise, consumers care about the environment, but at least from what we know internally, not
as so much to be willing to pay the same price for a refurbished product. So what we are now doing is to provide the refurbished product with a discount on that. Yeah.
So the cost is now with Philips then. So you.
Yeah, what you have to consider is that there is still quite some gain for Philips, because all these units would be scrapped otherwise. So it's a unit that would end up in a landfill, and instead now you're still making a profit, even if it's much smaller compared to the profit that you make with selling a new unit. You're still making a profit that otherwise would not be there. And we are really talking about a huge amount of products. I think Bas was briefly talking about that at the beginning of the call. Consumers are really going crazy with e-commerce. When you have to buy a vacuum cleaner, you buy five of them just because you want to try them, and then you want to send that back the other 4 that you are not going to use. So like Philips, but I suppose that all manufacturers in this moment are really getting back huge amount of products. We are talking about millions, the scale of million products. Yeah, so this is a really huge problem.
And they're all sent back and forth, I think. So you buy 5 vacuum cleaners and you send back 4. It's a really strange situation where we're in currently, I think. Yeah. So last week we asked around us because we were going to do a project on the Senseo, because that's the most repaired product at the Repair Cafe. And we're going to do a project on it. So we asked people around us if they still have one left. And currently we are almost at 8, I think. 8 within 2 days. We have gathered or harvested almost 8 Senseos. And a lot of people have just lying them around. And well, maybe they're replacing them with the new versions of it. But I think they actually work. And we're going to do this. We're going to actually work on this together with Julieta and Alma on 3D printing a complete Senseo. So for spare parts, there's no need, because actually in a half a month or a half a year, the spare parts will be available online via 3D printing. Just wanted to tell you that, Francesco. If it works, of course.
Yeah.
All right.
Yeah.
Yeah. Astrid, do you have a question? You're muted, Astrid.
Sorry, I always forget that I'm actually muted. I was very intrigued by what you said, that people actually order so many vacuum cleaners at once just to try, which I can't blame them. But then we should also work on the attitude of the consumers, right? I think that's very important. Yeah. And then I think children, of course, again. So maybe we should have a little chat about that sometimes, how we can, make sure that people understand what they're actually doing, because it's, well, troublesome.
Yeah, from Philips' side, it becomes very difficult to actually influence consumers on this, also because it's something that at the moment is really easy for consumers to do. So it really gets difficult to stop consumers from ordering 5 products instead of just the one that they want. I suppose that possible ways of disincentivate this behavior is also to make them pay if a certain fee if they send back the product. That could also be a possible way. From the manufacturer perspective, many times you are very limited in that, also because there are these resellers in the middle, for instance, Amazon, that are 10 times Philips. So Amazon makes the rules usually, and Philips has to find a way to deal with that. So yeah, I suppose that this is really something that resellers should definitely tackle.
Well, we could move on to some kind of panel discussion, but I like the questioning, which I see a lot, and maybe people who have been presenting can join in. So, like Astrid, can join in the discussion which we have on repairing, and also about, well, all this kind of transportation which is involved, which actually Karel shared with us. Stijn, do you have a question? It's about medical devices. I know, I think Sharina and Stijn are both working on medical devices. So,
yeah, so I'm currently doing my internship at Philips at the moment, and I'm doing a redesign on the transducer collection. And I've been talking with quite a few hospitals now. And the big problem there, which I encountered, is that they always choose new devices over refurbished or repaired devices because they think they are inferior. So I was thinking, even if Philips would make all their products circular, it's still a difficult challenge to convince them of these products to buy them. So I was, yeah, it will be just an open discussion. How could you convince these people to buy these products?
Yeah, I think that is it for me? Sorry.
Yes.
Is that the question for? Yeah, like that's definitely a huge problem. So it's also user perceptions about these refurbished products, and we are seeing that is a bit changing, and also depends from the regions, the market region. So, for instance, Europe and mainly northern markets like the Netherlands and Benelux, people are quite open to the idea of having refurbished used products, while instead other regions, for instance, the North America market is much more challenging in that perspective. So I think that Astrid was also talking a bit about that. Refurbished repair products are seen as inferior, as like poorer solutions, and many people still prefer to go for the newer version. What we are seeing right now, at least for the DACH market and also Benelux, is that people are instead very open to that. So for the refurbishment, we officially started to also have shavers in the refurbish, so more personal care products. Also the Lumia, it's a very personal product. It's a product that you use to epilate your skin, so it's something that really goes directly in contact with consumers, and consumers are actually willing to buy them also, even if they are refurbished. For medical, the big medical equipments that are currently refurbished have a good market, mainly also in those countries that are a bit perhaps poorer. So for instance, if you think about Turkey or these developing markets that are a bit like behind Europe and the US, they are more than willing to get these refurbished products, because NMR machine, we are talking about millions of euros. So yeah, they really don't have any problem to save some thousand euros there. So I think it really depends from the market region and also, of course, the type of product.
Yeah. And I think just relating a little bit to what Astrid says, it's not its current state at this moment. So people are not willing, or maybe they can even buy the new versions, and they might be a little bit reluctant on buying refurbished versions. But I think that can change, and that will change if we are going to change, well, the new generation. And I think also about what I think about our students. We have 350 bachelor students every year. And if they become, just like you are, Stijn and Sharina, they will become the new generation designers. So actually, you're already indoctrinated in, well, taking these kind of products to a next level. And I think what Francesco is already starting that one up at Philips, so it's a good thing. So we are definitely in need for young people to participate in this. Astrid.
Yeah, but I think that's true. But I'm not sure if, because I think young people like you should be the influencers of the children now, because most children don't even realize that you can actually fix things that are broken. It's just normal to throw things away. So it's not even a choice. It's just in their minds, there are no other options. So it's very important for young students and young designers like you to be present in the lives of children in some way, so that you can actually show this different perspective on how to be in the world, because most children just don't know. It's not even a choice. It's just a complete lack of knowledge. Yeah. And the parents, they sort of forgot or feel incapable themselves, because I also found from my talks to parents that some parents don't get into making because they're afraid they'll be a fool in front of their children because they're not able to. So if they're not a master at the skill, they're not prepared to show their children these things. So I think it's very important, you as a young role model, to be visible in the lives of children. So I definitely feel we should connect and continue this in some way, because this is such a huge bridge that we can actually build towards the children that are really in need of these types of knowledge. I feel really empowered by your presentations.
All right. Anybody else who want to add to this?
I would like to ask a question to Francesco, referring to his presentation, which I found very interesting to see that Philips is exploring so many different business models to kind of like be able to transition to the circular economy. I was wondering, because I didn't see so much. So as I see it, Philips wants to continue having the repair on their side, right? They are not. Are they considering end users for any kind of product, or are they always? Do they want to keep holding on to doing the repairs or refurbishments? I mean refurbishments,
Yeah.
of course, but themselves?
Yeah, I think that this was the key questions of of today for Philips. Yeah, so the official line at the moment is really that repairs should be done by authorized repairer, and there are quite some reason for that. And of course, people can agree or disagree on those.
Yes.
And the main reasons are about the quality of the repair, the safety of the repairs, and so the overall quality of the work done. So all the repair centers that are under Philips followed strict standards, quality processes. They are trained. They get updates, update trainings. They have to follow very strict sanitation procedures. So there are all these different things that, for instance, in Repair Cafe, we don't have. And I think that is also because we are talking about two very different things. I think that self-repairs are definitely extremely important for circular economy and to extend product life, because after the warranty period, the cost of a repair can be too high for many consumers. We were talking about Senseo, and Senseo you can buy it for 40, 45 euros on the internet. And if you would go for a repair, you would at least spend that amount of money. So it's completely clear why self-repair is important. But at the same time, Philips has an image that has to take care of. Of course, there is the safety of the consumer that try to repair, for instance, an AC machine. With Giulietta, we looked partially on this topic. Our research, I think, was not sufficiently complete to have final outcomes on that. But we really saw how even students from TU Delft, so with a technical background, would have had serious problems, safety problems in repairing, I think in that case was a coffee maker. So I think that the safety issue is an extremely important one. Yeah, it's quite a big of a risk for manufacturers at the moment.
Yeah, I do understand that, but I can tell that some things you can repair by yourself and some things you should get away from. So when it becomes actually really dangerous, don't do it, but or let somebody repair it by himself. But some things can be repaired by people. Are you thinking about, well, there's some gray zone in between. Don't do anything and let us do it, or well, you can do something. You can empower those people as well.
Yeah, for sure. So I think that there is a very big distinction to be done, first of all, between AC products, so high voltage intensity products, so coffee maker, vacuum cleaners, these kind of things, and battery power products. So of course, battery power products are safer to repair, even with low experience. At the same time, also with battery power products, you could have some consequences. So for instance, Philips shavers at the moment have a very high reliability. They've been optimized for years in their design. So they are completely watertight. They are very durable. They last a very long time. Making the design easier for repair, for instance, might hinder their durability. That doesn't mean that we should not do that. And that's what we are currently working on, so to really go into these challenges. But these are the main reason why today products are not as easy to repair for self-repairs and consumers. Most of the other products, so for instance, also coffee makers and vacuum cleaners are instead quite easier, for instance, to be repaired by professional repairers. So if you have a complete training, then in that case, these products can become actually very easy to repair because you know how to do.
Yeah, for now, but I just want to add to this comment that I guess that, well, from our research on safe by design, we also came up with different possible solutions to support or make this self-repair safer and whatnot. And I can imagine that not all of those are applicable to all product types, but I can imagine that you can, like Bas said, like you can provide certain information in a certain product group, but also we also talked about foolproof design. So how can you like cut the power? How can you have differences there that allow you to do these things?
Yeah. And I think that, for instance, the biggest problem is the very low price tag of the product. So all these all these solutions, design solutions that you can implement in the product to make it safer, can improve increase the cost of the product. So the challenge there, as we know very well, is really to try to identify very effective design solutions that don't increase the price. So yeah, that's definitely something that has to be looked at.
Yeah.
Right. So Astrid asked something if the self-repair should be an indicator on the packaging. Hey, wow. What do you think?
I'd be happy to pay extra for something I can fix myself with maybe little instruction in it. Because as a consumer, there's not always a more sustainable option when I have to get a new vacuum cleaner or coffee machine. So if I would have a choice.
Yeah, I think that also there it gets very complicated when you get this big production scale, right? So we were talking about markets, we were talking about different type of consumers. I think that what we know is that most consumers are a bit different compared to you, Astrid, as you were saying before. So for instance, you would be willing to pay more for a product that is more repairable, while instead a lot of our other people would not. So people love to save some money, even if you're talking about 5-10 euros on a shaver. It's a very huge difference, and the level of marketing can make a huge difference. So I suppose that is also about trying to understand. I think that it's very tricky to address this problem if we are going to increase the price of the product. We can do that only in the situations when it actually makes economic sense. And that could be the case when we have a circular business model. So if the ownership of the product is not on the consumer anymore, but is on Philips, then you might have much better reason to actually spend more on the factory cost price of the product, on the BOM of the product, on the production cost of the product, because then you save that money in the long term on the throughout all the different operations that you do on that product.
All right, I see people are leaving already, so I think we're going to close down this session. I had some statements which I would like to have your reaction. For instance, which product is not allowed to exist at all? And I think one of those is the fidget spinner. I've got it over here. This is the fidget spinner, and I think it's not allowed to exist at all. It's no functionality, and but that's why I like Dieter Rams from Brown, and he made this 20 principles or 10 principles of good design in the 1970s already. That good design is long-lasting and good design is environmentally friendly. And I think we still have to pick up this space in the 2020s, which we are in currently. But I would like to close down the session. Wait up, these are all. So yes, I would like to tell you a little bit on next Saturday, this Saturday, the 17th of October, 2020. It's going to be International Repair Day. So actually, I was wondering, committee or a panelist, what product are you going to repair this weekend? Or did you think about, of course, because you know it's International Repair Day. So who wants to start? Or anybody, if you want to join in, anybody.
My bike needs some repair here and there. So that one's a good weekend project.
And
Yeah,
I see. Sorry.
Sorry. Yeah, no, I have pending a repair that I have been wanting to do for a long time. I need to repair the needle of a Technics turntable for a friend, but it requires some soldering of the audio cable. Well, not the audio cable, but for the signal of the needle to the what's called the amplifier.
Yeah.
So I don't know if I would do it, but yeah, that's kind of pending.
Well, Saturday's the day off where you can do this. So
Yeah,
I see
he would be very happy.
Sharina's going to mend her 3D printer, I think. You cannot, Sharina. I know you cannot talk now, unfortunately. Anybody else? Sewing machine. Alma.
Yeah, I got a sewing machine secondhand, and I already fixed one aspect, but it's still missing the kind of table that you can attach to it to broaden the workspace. It only has like the small arm left, because you can take the table off, so you can, for example, sew your sleeves. They're sort of this big, so you can take off the table and place your sleeve over it. But the table is not there, so I can't use that, and I would like to use that. And there's also some other part which stops the spool at the top. That's also missing. So if you wouldn't use anything to replace that, the spool would just come off and you start sewing. So now I've got like a little piece of foam that folds it in place, but of course now I've got a 3D printer, I might make it more.
All right,
aesthetically pleasing design.
Excellent. I see Jan really wants to join in with you because his pants has to be repaired and Julieta's sleeves have to be repaired. So maybe Jan, you can join in the afternoon while Alma is preparing her sewing machine before that.
Yeah, sounds good, but it's just a small hole I need to fix actually.
You can do it by hand, isn't it?
Yeah, I think that can be done by hand.
All right, excellent. Anybody else?
I was going to say, I have a iPad screen holder in the library we use for exhibitions, and the base is completely broken. So I plan on repairing it, but it probably will require milling a new base. So a little bit of new material involved.
Yeah, that's a good thing. That's a good thing. All right. I'm going to repair my video camera because I bought this camera when my first child was born in 2004. And actually the videos have never been transferred to my computer and it went broke last week when I tried to do this. So I have to fix it. So because all these old video tapes, tapes and that's where my kids are on. So I really have to mend that one. All right. Yes. Okay. So better for me to, well, I'm going to close down this session. I really enjoyed all the presentations. Thank you very much, Karel, for your interesting story about material streams and in cities. Thank you very much, Sagar, for your diagnostics and the user perspective on that. I'm really looking forward to the next steps you're going to make together with Beatrice. Thank you, Astrid, for giving us some insight and your work on well prepping the new kids on the block. And I looking forward in 10 years when they come around over here at the university and become the new designers. Thank you, Alma and Julieta, for 3D printing in repair. And I know you've been working on this only for 1 or maybe 2 weeks. So I think thumbs up for what you've done so far. And I think it's good to see that where you need 3 iterations at least to get to a result which is acceptable. Thanks, Francesco, for joining us today and giving some insights in what Philips is doing and what you actually think and Philips is thinking about repairability. And I'm really happy that things are moving towards a more circular economy and towards a more a better environment where we can well live happily ever after. Thank you very much. And thank you, Vincent, from the library, which has organized this one. So Vincent, Thank you very much.
thank you.
And
Well, and we have to thank you, Bas. So that's the last thing.
so I would like to invite all of you for a beer now, but unfortunately, that's you have to do it alone at home, just like me.
We're going to take a Corona check on that one. So we're going to do a reunion event.
That would be nice. That would be very nice.
And you know, and if you're happen to be in the library, please do check out the Repair Cafe International exhibit or online. But thank you again to all the panelists. It was a delightful conversation.
It was. Thank you. And I'm going to show you the last one. Design Beyond Generation, because Professor Connie Bakker has done or is doing her presentation currently. And she's going, so if you want to join in, there's the Zoom link, and just type in the number and you can attend that meeting as well, where a lot of good designers will tell about future design. Thank you very much, and hope to see you next time. And well, let's keep in touch with all of you.
Yeah, I think
Thank
we're
you.
going to see each other at the Dutch Design Week, right?
Yes, next week.
Design week.
Next
Bye.
appointment.
Bye-bye.
Everyone stay safe and take care.
Stay safe. Bye-bye.
Bye.